So we're going to get into prepositional logic here, and this is mostly formalizing logic with rigor attached to it. So prepositional logic is based off of prepositions and how they relate to each other, how you can combine them, so on and so on. So typical notation for preposition is a P, and when more than one preposition is involved, you usually use P and a Q. So these are prepositions, and by that I mean these are statements that are either true or false. So these are either true or false. So think about, as an example, P could be I got the winning lottery ticket. This is a statement that is either true or false. Okay. And this is I got the winning lottery payout. Okay. So these are two statements, that are related to each other, or they can be. But the key is they're prepositions, though they're either true or false. And there's different ways you could combine propositions. One of them is with implications. Okay. And implications you denote with an arrow. So if I do P arrow Q, this reads in English as P implies Q. All right. Now, like I said, these are things that have true and false assigned to them, P and Q. So if I make a table, P, Q, P implies Q. All right. P could be true or false. Q could be true or false, but also we have to consider the other combinations if P is true and Q is false, and if P is false and F is true. So this is called a truth table. It's a table of true and falses of prepositions and different ways of combining them. So the way that you figure out the truth value of P implies Q, you basically think of when you can think of in this example of the lottery ticket is when you're winning here, when you are satisfied with things, and when you feel cheated or done wrong. So, for example, if P is true and Q is true, meaning you got the winning lottery ticket and you were given the payout, do you feel cheated? No. I mean, that's exactly what you expect, right? So that's true. All right. Now, this one here, whoops again, this one here, P is false, meaning, okay, you didn't get the lottery ticket. And Q being false means this statement is false, you did not get the winning payout. Well, that's expected, right? Because if you didn't get the winning lottery ticket, then you're not going to get the expected payout. You don't feel cheated there. You know, those are the rules of the arrangement, so you don't feel slighted there. Something like this, P is true, Q is false, would mean that you did get the winning lottery ticket, but you were denied the payout. That's where you feel like you were done wrong, done dirty. P implies Q is false there. Okay. Now, if it's reversed, in this instance, P is false, but Q is true. You didn't get the lottery ticket. You didn't get the winning lottery ticket, but you did get the payout. You don't feel cheated. You're running with that all day. So that is going to be true. You don't feel slighted there. So it's going to be false when, the deal cheats you. Okay. So you can make a table here. P implies Q, Q implies P, and follow the same way. And you'll see that these don't add up, meaning this column does not turn out the same as this column. So what that tells us is that P implies Q and Q implies P are not logically equivalent. Okay, so logically equivalent would mean that in each scenario, here, 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 and here, that these would evaluate to the same value. They're either both false or both true. And that's what we mean by logically equivalent there. So that's an exercise that you can work out. We'll stop here and get into more in another video.